So first, I will recap from the first till today. I'll take 5 to 10 minutes to recap the entire sessions that we have taken until today, and then I will continue with today's session. So this week, most of our time we were spending on what is an attribute view, what are different subtypes in an attribute view, what are different join types, and what join to be used in what scenario. When we actually started these sessions, we know in the first lecture that I delivered was demo lecture. In the demo lecture, we were seeing concepts of in-memory database, what is a column DB, what is massive parallel processing. In the second session, we have seen different systems and their integrations, usernames and password for each system. And then in the starting of this week, I started with taking a scenario and based on that scenario, creating attribute views. In the first session of this week, we discussed about what is HANA Studio, what is a catalog. Catalog is a collection of schema. We create catalogs based on data provisioning method. Catalog contains schema and schema contain database objects like tables. Tables are stored in memory. Tables are optimized for read access as well as write access. It can be optimized for reads as well as writes. That's the advantage of column tables. And then we started to discuss about content. Content is a collection of package. Packages are used to group information views, like how schemas are used to group tables. Views access data from these tables in runtime, and these views execute on data processing engines. When we create a package is to group together related information. Packages are associated to delivery units. A delivery unit is an object to transport information views from one system to a different system. We associate delivery units to package and we transport delivery units. So when you transport delivery units, we can also transport package and the associated information views. Then we started to understand the definition of an attribute view in the second session. What is an attribute view? Attribute views are used to join master data tables. Attribute views are the reusable dimension. A dimension is the perspective in which you would like to analyze data. Attribute views are optimized to process complex joins. Attribute views execute on a join engine. Attribute views have subtypes standard, time, and derived. A derived attribute view is a reference attribute view. A copy is like a template. Time-based attribute views are used to analyze, transaction data based on different time-based entities. These time tables are stored in sys underscore BI. Based on the calendar type and the granularity, the tables get selected. To populate data into these tables, we use generate time data option. Whenever we generate information views generate column views in sys underscore BIC. Column views are runtime views, and attribute views are design time views. Runtime views are consumed in front end. You can consume in business objects BI reporting tools. You can consume in Fury. You can consume in third-party systems like Tableau, TIBCO, Spotfire. And then we started to create an attribute view. The second class, we started to create an attribute view. So when creating attribute views, there are different steps that we need to execute. Step number 1, we need to make sure the required tables are replicated to schema. Once we have required tables based on the user requirement, create an attribute view. When you create an attribute view, you see data foundation. A data foundation is a place where we define a relationship between tables. We create foundation for data. So based on the business requirement, we add tables to the data foundation. Step number 1, add tables. Step number 2, define relationship between tables. Step number 3, define join types. If you join an attribute tables together, you can use any of the join based on different scenarios. You can use referential join, you can use inner join, left outer join, right outer join, text join. When you join an attribute table to a text table, we use text joins. Text join show description based on user session. So step number 1, add tables. Step number 2, define a relationship between tables. Step number 3, define join type. Step number 4, field selection for output. We select columns which are required by business. Step number 5, define key attribute. Step number 6, descriptive mapping, label mapping. Finally, activate. Once you activate, it generates a column view in sys.bic. And right-click data preview, perform unit test. Inside attribute views, we can create design time filters, nothing but constraints. Design time filters are used to filter data in a very early stage. What is the usage of limiting data in a very early stage? The less the data you transfer to the next level, the more the performance you have. So based on the business requirement, if you have to limit data, then limit it at a very early stage. The reason is when you limit data in an early stage, only the less number of records get transferred, and views give best performance. So the advantage of design time filter is it executes the filter before a join condition. Then we also try to understand when creating a design time filter, we can give system variable $language $. It is for single tables when we cannot define text joins. Attribute views are mainly used for master data modeling. We cannot do aggregation type of sum. We cannot do summation. It's only to define a relationship between tables based on entity relationship models. And then we have seen what is a derived attribute view. And then in yesterday's session, we have seen what is a time-based attribute view. In the end of the session, we have taken an example for inner join, and I tried to show you how and where we can use inner joins. So in yesterday's example, we wanted to see company code ID, name of the company code, sales organization ID, name of the sales organization, currency ID, and name of the currency. So when we are joining company code table to a sales organization table, we have defined the join type as inner join because we would like to get common company codes between both tables and associated sales organizations. Until this, we have seen in yesterday's session. So in coming week, what is our focus? My complete focus on the next week would be, we will take a scenario called profitability analysis in CO. I will explain end-to-end scenario on profitability, and then we will start to create analytic views. So the whole week we only focus on attribute views. In the next week we'll focus on analytic views, and the end of the next week we will focus on the calculation view. So whatever attribute views I created this week, I'm going to consume these attribute views in building multi-dimensional views or star schemas. We're going to create star schema or a star schema. A schema represented in a form of star. A schema is nothing but collection of tables. You're actually collecting a tables, and these tables are organized in such a way they're representing star. The advantage of creating a schema in a form of star is you can do multi-dimensional analysis. So one scenario, you can do different kinds of analysis, different ways to analyze data. That we will see in the next week. So today, I'll continue to create the same exercise for AT company code. So I'll go to the HANA Studio. So let us log into the remote desktop connection. Let us click Start. Click on SAP HANA Studio. Click OK. Double click on System. Provide the username and password. Expand content. Expand package. Right click on the attribute view folder. Click New. Provide the name AT company code. Let us provide the description subtype as standard, view type attribute view, click finish. Once we click finish, so in the yesterday session, we want to create a view of something like this. We want to create a view which has four tables, and each of these tables have following columns. So this is the attribute view, and this is what we want to create yesterday. So these are the different tables. So first I'll pick up all these four tables from HANA user schema. I'll go back to HANA Studio. At the data foundation, I click on the plus icon, add these tables T001 from HANA user. So T001 from HANA user. So let us select, click OK, and then TVKO from HANA user, click OK, TVKOT from HANA user, click OK, and TCURT from HANA user, click OK. So now the four tables, I have all the four tables I add to the data foundation. We are creating foundation for data based on these four tables. So let's go back to HANA Studio. So in order to have more work area, you see details pane, you need to scroll every time. You need to scroll. We lose visibility on the tables. So HANA Studio, in HANA Studio, we can customize according to our requirement. So I'll just try to minimize everything. I'll minimize this. I'll minimize the systems area. I'll close the scenario pane. I'll close the output pane. I close everything. And I have more visibility on the details pane. So now I'll select HANA user dot T001. HANA user is a schema dot T001 is a table. HANA user dot TVKO is another table. And TVKOT and the last table TCURT. So we have these four tables. Now, based on these four tables, I'll join T001 BUKRS to BUKRS, TVKO, VKORG to VKORG of TVKOT, T001 WAERS, nothing but the currency ID to the currency ID. So I'm basically joining these four tables based on three join conditions. This is an inner join, this is a text join, and this one is a text join. First, I'll go back to HANA Studio. I'll join BUKRS to BUKRS, VKORG to VKORG, WAERS to WAERS. And now join type. Select the join. Join type is an inner join. Join type is a text join. Join type is a text join, and the last one here, the join type is a text join. Now we know why we need to take text join. Whenever we take text join, we need to take SPRAS, language column, and here we need to take SPRAS, language column. So both these are attributes, company code and company code. So now what is my requirement here? So what columns I need to take to the output? What columns I require for output? I require BUKRS, BUTXT, VKORG, VText, WAERS, and LText. So these 6 columns I require for output. Now this I can get from T001, TVKO, TVKOT, T001, and TCURT. I'll go back to HANA Studio. So what I'm trying to do now, I'm trying to do a projection. This is known as minimal projection. Minimal projection is selecting required columns to output. So company code text. So whenever I do a selection, these columns are available in the output. If you don't require a column, right click and remove and click yes. It doesn't highlight. So if you want, click WAERS, LText, currency text, VKORG, and VText. So the 6 columns I have over here. Now I add tables, I define relationship between tables, I define join type, I define field selection for output, and finally, again, let's open. So you see there is an arrow here, and you can just click on this. You can select, drag to right hand side. So this is the data foundation. So based on the data foundation that I define over here, I click on semantics, select at least one key attribute. So please see here, we have 2 attribute tables. In here we have 2 attribute tables. Now how do I know what key I need to take? Because T001 is a company code table and TVKO is also attribute table, which is sales organization. In here the key is BUKRS. In here the key is VKORG. Here it uniquely identifies company codes. Here it uniquely identifies sales organizations. But what is my subject area? What subject area am I talking about here? We're talking about company code subject area. So when you're talking about company code subject area, we need to take BUKRS as a key. If you're talking about sales organization subject area, we can also create another attribute view called AT_sales org. But when we're creating AT_sales org, we can take VKORG. So based on the subject area, we're defining the key attribute. So in here, the central entity table, so I'm actually talking we're discussing something called central entity. You see there is a property here. When you click on the data foundation, so there is a table which is actually the center table. In the data foundation, the center table is T001. Always please remember, we need to join on key attributes. We need to join on a key attribute. It gives best performance. When joining on key attributes, it gives best performance. So BUKRS is a primary key, and here it is a foreign key. VKORG is a primary key, and here it is a foreign key. WARS is not a key attribute. It's only an attribute. So this is a primary key, and this is a foreign key. It's non-key attribute, but still it is a primary key. It's not the key of the table, but it's an attribute where I'm joining the T001 WARS with WARS of TCURT to get text. So in the semantics, how do we know what key we need to take? Based on the subject area, company code. And the company code BUKRS is the key attribute. So if you take sales org, we need to take sales org as the key attribute. So at least one key attribute, and then descriptive mapping. And hide the descriptions. So why do we hide descriptions? We would like to show key and text. In the report we have key and text. Key is taken from here and text is taken from label columns. It displays in a single column. Rather than displaying in two columns, it displays key as well as text. Finally validate and click Save and Activate. Let's open package. Right click on AT company code. Click data preview. Click data preview and click raw data. Now let us do sample test for raw data. Let us do a sample test. So because descriptions are in Chinese, it is difficult for me to understand Chinese. So I'll just switch back to right click on the system, properties, additional properties. I'll take in English. I'll take in this English. Click apply and click OK. Let's go back to the package. Again, right click, data preview, click raw data. Now let us do a sample unit test. Whatever we are doing is correct or not. Let us do a sample unit test. Click add filter, click BUKRS, click show list of values and select 1000 company code. Select a selected value and click OK and click execute. Now here we would see company code. Company code operates in what currency? German operates in euros. And this company code, just I'll drag and drop here. I can select and drag and drop the columns over here. So company code, this company code BU Caris has 7 sales organizations. So 7 rows are retrieved based on one company code. So one company code has 7 sales organizations. These sales organizations are the output of the inner join. So based on the inner join, the company code of company code of T001 join with the company code of TVKO produce 7 rows that put 7 rows from sales organizations. So if you want to test this, whether it is showing the right sales organizations or not, and right currency or not. So what sales organizations in 1000 in Germany? Frankfurt, Berlin, Hamburg. Frankfurt, the code is different. CPC1 and 1000. Fin Services, Deutsch and organization. Something in German over here. So I'll go back to ECC. I'll log on to ECC. I'll just do a sample test. I'll log on to the ECC. Let us give the username and password. Let's continue with this log on. Click continue. S11, enter. Database table name T001, display. Contents, click contents. Click contents. What is the company code? Click execute. The company code is 1000. So what is 1000? Best run Germany. So I'll pick up 1000 from T001. I'll create session again. Create session S11 is a T code to view tables. Enter. Give the table name TVKO. Display. Click contents. Enter the company code 1000 because I'm doing an inner join. I'll enter the company code 1000. Click number of entries. 7 entries. So 7 rows in HANA. 7 sales organizations in TVKO table. Click close. Click execute. So for 1000 company code based on the common company code, these are the 7 sales organizations. So these are the 7 sales organizations in the output of the TVKO table. So here, the sample data here is 1000. And so if I go to T001, the sample data here is best run Germany. Just I'm creating a test case. 1000 best run Germany. And this is based on this. This is we are retrieving the sales organizations. Now for this 7 sales organizations, I need to retrieve the text. I need to retrieve the text. So to retrieve text, I need to log on to TVKOT. I need to log into this table. I need to display this table. Create session. S11, enter. Enter the table TVKOT. Click display. Click contents. So here I need to enter the sales orgs. We have multiple sales organizations. So I'll click on this icon, multiple selection. Copy the 7 sales organizations. I'll go back and copy again. I'll go back to this column copy. copy this. I'll come back to TVKOT and I'll copy paste, Control V, and click execute. So what's the language? I require English. So we need to see the output for V text execute. So these are the 7 sales organization text. So I'll go back and copy this from the source system. So these are the 7 text I got from this TVKOT table. This is sales organization. This is company code and currency. And then finally, the currency. For the 1000 company code, what's the currency? So let's go back again to T001 table. Let's go back to T001 table. So for this, the currency is, you see here, euros. So this is, when I click back, T001, so this is the column. WAERS is nothing but the currency key. So I'll display the currency text table. Create session, S11, enter. The currency table TCURT, display, click contents, enter the currency code, euro, enter the language key, number of entries, 1 entry, close, execute, euro. This is the ID and this is the text. And this is K text, short text and long text. So this is the text. So I'll go back again. And this is the text. Now let us compare to the data that HANA produced for us. So let's go to HANA. And now let's go to HANA. And now let us see. So 1000 company code. Name of the company code is Best Run Germany. 7 sales organizations, 1000, 1020, 1030, CPC1, FS01, TM2, Jet000. The 7 sales organizations. The text for 7 sales organizations. The currency is euro. WAERS is euro. And the long text, this is L text. So hence, we completed the unit test for company code. And then later we can transport this object. So this is how I created 80 company code. And then we are trying to see how an inner join functions based on common condition. Equi-join. So I'll create one last dimension which we will be using on the Monday class. We'll be using even this dimension. If you remember, when I started the initial requirement, if you remember my first requirement, we wanted to create customer attribute view, we want to create company code attribute view, and we also wanted to create material attribute view. We completed customer. We completed to create customer. If you remember my initial requirement, I've taken as a functional spec. Then we wanted to create 80 underscore material, and we wanted to create 80 underscore company code. So one last one is left, which is AT material. Now for AT material, materials are available in Mara table. Like here there are 3 tables for customer. For company code you have 4 tables. For Mara we have 2 tables. So KNA1, T005T and T005U, company code T001, TVKO, TVKOT, TCURT for material Mara and MAKT. So all these tables, all the tables that we are seeing here, they reside in a schema. All these tables reside in a schema. The schema name is HANA user schema. HANA user schema is in the catalog. So all these tables, and here you have views. These are views inside these tables. These views are in content. Under content, we create a package ECC March 8. March 8 is a package. So content, package, under package you have these different information views. And these views, the views that you see here, all these different views execute on an engine known as join engine. Join engine is internally represented as JE. So whenever we generate these views, these views in the catalog also generate a column view in sys_bic. So if you want to know the column view name of a particular view, so tables in the schema, views in the package, views execute on join engine, views create column views in sys_bic. If you want to know the name of individual column view for a information view, go to HANA Studio, right click on an attribute view and copy column view name. Copy column view name for this and let's paste it over here. So this is the column view name for the company code, sys_bic package/AT company code. So this is created for this, and this column view basically indirectly executes on join engine. And the column view consists of output. Column view consists of output and it consists of the code. The code is an SQL script that is generated by system. So what's the output? So we have 6 columns. Based on these 4 tables, the relationship between 4 tables I define, we got an output. And the conditions that we actually given over here. So if I go back to HANA Studio, I'm just trying to explain the entire process. We go to the catalog, go to sys_bic, go to column views. I click on the column view and click filter, copy paste the column view. Just remove the schema because we are inside the schema. Whole word, click OK. So here we see the column view. Double click on the column view that is generated by an attribute view. So these are the 6 columns for the output. The 6 columns are nothing but the output is nothing but the semantics. Create schema. So this is the code that is generated by system. And when you right click on this and click open data preview, the code is being executed. And it shows the following columns to the output. Now when the code is being executed, the code is executed. When you open data preview, now it executes the code. The code is being executed on what engine? To see the engine for an attribute view, click on the data foundation, click on the free space. When you click on the free space, here you can see a column engine, which is a join engine. The join engine internally represented as JE. That's what I'm trying to show here in the diagrammatic representation. So when you create an information view is based on tables. Tables are under schema. Schema is under catalog. Tables are used in the information view. Information views are grouped under package. Information views create column views in runtime. These runtime objects execute on join engine to produce the output of the view. So how I created AT customer and AT company code, now I'm going to create AT material based on Mara table and MAKT. If these tables are not available in schema, we need to do data provisioning. We have to provision data from source system. This source system can be ECC or a non-SAP system. So we provision data from source system to the schema in the catalog. So the way that we can provision data, SLT, BODS, DXE, Smart Data Access, we have different ways we can produce. So based on the business requirement, if you do not have these tables, you can provision. This is in the sidecar scenario. Or the other way is you directly have ECC powered by HANA. So when you powered by HANA, you directly have tables on HANA system, like S4 on HANA. So either you can take tables and create data models in the native HANA. Native, what is native HANA? Inside HANA database. What is my native place? My native place is different, but I'm staying in different place. So we're creating data models in native HANA by taking the tables from ECC. Either you can replicate in a sidecar scenario, or you can have the main car where ECC is powered by SAP HANA. So now AT underscore material Mara and MAKT. Mara is a material master table and MAKT is a material description table. So I can join both of these tables by using Mara, or in Mara I can use MAKT. I can use MATNR. MATNR. MATNR is nothing but the material ID. MATNR is nothing but the material ID. It's MATNR. So I'll go back to HANA Studio. I'll go to the package. Right click on the attribute view. Because I want to complete this scenario, AT underscore material. I'm creating a material attribute view. Click finish. Let's click finish. Once we click finish, click on the data foundation. Click on the plus icon. Add objects. Mara. You see, here we have two scenarios. One is Mara from HANA user. Again you have Mara. This is main car. So how do we know it is main car? And how do we know this is sidecar? Because here you can have the same table Mara on HANA. In a sidecar Mara, you can have the different schema. So I'll just try to show you how we can identify whether it is a main car Mara or it's a sidecar Mara. So if I go to the SAP logon, so here you see there is a system called S4 HANA. I'll double click on S4 HANA. I'll give the username Surya, password Surya1234, enter. Continue with this logon, click continue, click systems, click status, click systems and status. Now in here you see something called database, HDB, means HANA database. Owner is nothing but where this database tables, where the tables of this system reside. It is SAP ABAP 1 schema. So if I go to HANA, you see Mara from SAP ABAP 1, Mara from HANA user, main car, sidecar. If I go back to S4 HANA again, system again, owner is nothing but the name of the schema in which these tables are residing. I'll click close. I'll enter the T code SC11, click enter. Give the table name Mara, click display, which is material master table. Click contents, click continue. Number of entries, we have 20 entries. Click close and click execute. So these are the entries I have inside the system. So the same Mara table, this is the Mara table. So when I select this SAP ABAP 1 Mara, when I right click on this table, open data preview, click raw data, I can see these entries in HANA as well. So you can see entries for Mara table. You can see entries. We can see entries for Mara table on ABAP, MATNR. You can see entries for MATNR. Here you have 20 rows. Here also you have 20 rows. This is on the HANA side. This is on the ABAP side. This is main car scenario. Let me show you sidecar. If I go to ECC system, click systems, click status, click systems, click status. Here the database is MS SQL. From MS SQL, I need to get Mara table to HANA. This is a different database altogether. From MS SQL, I need to get to HANA. So when I want to get from MS SQL, that is from ECC, if it is on MS SQL, I need to use these different data provisioning methods. If I have the table on HANA, then why should I use data provisioning? For this use case, it is not necessary because the tables itself, ECC or the S4 is residing on HANA. So what I'm trying to say over here is, you don't have to do data provisioning when you have Suite on HANA or S4 on HANA or ECC on HANA. We still continue to use data provisioning even when you have ECC powered by HANA, but not to replicate ECC tables. But this is to replicate data from different source systems. These source systems could be non-SAP source systems. You want to consolidate data. Means data provisioning is mandatory whether you have ECC powered by HANA or sidecar scenario. It doesn't mean that we are actually getting tail from ECC, but we can use for different use cases. Like you want to get data from Hadoop, you want to get data from a different database, from MS SQL, or you want to get data from Natisa, from third-party systems. So still we continue to use data provisioning. To keep it very simple, Mara can be on main car, Mara can be on sidecar. For sidecar, we use data provisioning. For main car, ECC, ECC or S4 HANA, ECC or S4 HANA is directly storing its tables on the HDB, HANA database, and this is a schema in which it stores. So when I'm doing HANA data modeling, I can choose to select tables, Mara. I can choose to select from a sidecar, I replicate it to HANA user. From main car, I have on the SAP ABAP one. But here I'm using sidecar table, so I'll select Mara. So both we have Mara tables. So I'll delete this table now because I'm not going to use this. We're going to use this table. We will discuss one scenario called HANA Live. HANA Live are the operational data models that are given by SAP. Predefined data models. The advantage of using HANA Live data models, first is SAP has already pre-delivered, so we don't have to build from scratch. Second one, we don't have to replicate data. Third one, operational reporting. HANA Live is a solution for operational reporting, not for enterprise data warehousing solution. It's for operational reporting. No need to do modeling again. These models are predefined, provided by SAP. So HANA Live you can implement when you have Business Suite powered by HANA. So I'm not going to use these tables now. I'll remove the table. I'll just use from sidecar. I'll right click on the free space again, add tables, MAKT from HANA user, click OK. So just I'm trying to show you the difference between Mara on the sidecar, Mara on the main car. Nothing but sidecar, we use provisioning tools to replicate. On main car, we don't have to use because application itself is residing on HANA system. That difference I wanted to show. So now we are using from HANA user means it's a sidecar scenario. So if you use tables from SAP ABAP one, you're choosing from main car scenario. So MATNR, I'll join to MATNR. Join type, I select text join. Language column, I specify SPRAS. MATNR is the material ID, and MAKTX is the material text. Join type is a text join because we are retrieving the description. Material group, MATKL. MATKL is the material group. Click on the semantics. Click on the key attribute, MATNR. Provide the descriptive mapping, MATNR material ID and material text, material group. Validate. Click Save and Activate. Now, you can see material attribute view activated. Right click on the attribute view, data preview, and click raw data. Here you see material ID. For each of these materials, what is the description? Each material is grouped. What is the ID of the material group? So this is how I created AT material. If you want to do a sample test on this, we can go back to ECC system, go back to the ECC system. I'll click back and enter the table Mara. Because we already done this exercise multiple times, so I'm just showing you again. Mara display, same procedure, it is same procedure, display, click contents, Let us take one material ID. Let us take this 637. I'll copy this material ID from HANA and I'll display in the source system. I'll display in the Mara in the source system and click execute. So this is the material ID from Mara, material ID, and this material ID is associated to material group. So what is the material group over here? MATKL. Let me double click. MATKL. It's blank. So there is no material group associated for this material. So in HANA also, the material group is blank. So what is this material? MAKTX. So I'll go back to MAKTX. Same again, I'm doing the same procedure. MAKTX. Sorry, it's MAKT. MAKT is a text table. Click display, material descriptions, click contents. This is the material ID. Language key and execute. So what is the text? Adjustable bracket. Go to HANA, adjustable bracket, the sidecar scenario. So now I completed creating of 3 attribute views: customer, material, company code. And we have seen what is a derived attribute view, what is time-based attribute views, what is design time filter, what is a column view, where these views are executed, what is a content, what is a delivery unit, what is a sidecar scenario, what is a main car scenario, and how these tables are stored in HANA. And more details into this. We'll see more in detail about each of these views execution, how these views are executed using visualize plan, how to do performance optimization. Now this is okay when you have small sets of data giving appropriate result. But when you have large sets of data, how we can do performance optimization? Where can we check performance? How to debug the performance? We will see in something called visualization plan, visualize plan. And what engine does these views execute on? So until this week, we created attribute views. So starting from the next week, we will create analytic views based on the continuous scenario. I'll continue the same scenario, but let's start to create analytic views from Monday. So if you have any questions, please raise your questions in the chat box. I'll read out the questions and answer your questions. Thank you. So the first question here, what is the difference between an inner join and a referential join? The question here, what is the difference between an inner join and a referential join? Okay, So we know in today's session, by today we should be able to understand what is an inner join. So inner join is a join which is nothing but an equi-join, which get common values based on a join condition. Now what is this referential join? How a referential join is different from an inner join? Let us take one example. In sales, we have two tables. One table holds header data and the other table holds item data. Can you tell me a scenario where without header items are created? Without a header in header table, items are available in item table. Is there a scenario where you can find without a header items are created in item table? No. Why? Because there is a referential integrity between the header and item. Only when you have header, you can create items in an item table. So there is a referential integrity maintained. It means that the values that you have in the header table, only then you can have values in the item table. So obviously there is no scenario as such where you have items and no headers. Okay, this is called as referential integrity. Now how is this referential integrity related to referential join? Now, we already know header table and item table has a referential integrity. Now, why should I again tell to system based on equi-join, based on a condition which is an inner join, again check for data. Already I know the values that I have in header, I'll have in items. So what is the need to tell to the system again, okay, go and check for common values. Obviously it will have common values, so I don't have to tell system again, okay, go and check common values and do an inner join. So what is the difference between inner and inner and referential is, referential we are already telling system it has common values. In inner we are telling system to go and check for common values. In here we know, in there we are telling system to check. So what is the advantage in both the cases? In both the cases it does inner join. It does inner join, but when you maintain referential integrity, it doesn't check in the item table. But inner join it checks. So if you ask me, if you check it is faster, or if you don't check it is faster? Obviously if you don't check. If you don't check, we know it is same, so we don't check, so it is faster. So now tell me, inner join is faster or referential join is faster? Referential join is faster because it doesn't check, because referential integrity is maintained. So that's the difference between inner join and left outer join. In inner it checks, in left outer it doesn't check. So it acts like a left outer join. So left outer join is faster than inner join because it gets all the values from the left side. So from performance point of view, if you know that already a table has, in a scenario like header and item, we know already referential integrity is maintained. Now why to go for inner join? Go for a referential join. It increases the performance of a join. That's the importance of the referential join. But on the other side, there are disadvantages for referential join. Now what is the disadvantage? The disadvantage is there is inconsistency in the system. Due to this inconsistency, there is no header value. Let's say in the header we deleted data. We delete the data in the header, but these values are maintained in item. And then you do a referential join. It produces wrong result. The disadvantage is only if you're 100% sure that these values will be same at any point of time, go for a referential join. If it is not same, it produces incorrect result. Because it doesn't check. Still you have values in the left side, it produces incorrect result. So always it is mandatory to make sure 100% we are sure, but both values exist in both the tables, and only then the referential join condition works, and then it gives good performance when you compare with inner join. So next question. Can we have more than one key in semantics? If yes, when? Yes, you can have more than one key. You can define more than one key. It means that you're defining a composite key. More than one key you're trying to define in a composite key. But one key is mandatory. You need to have at least one key which is mandatory. If you want to debug, can you able to debug the code which has been created in sys.bic? Yes, we can do that. Using SQL script debug editor, we can debug the code in sys_bic. How will we create schema in the main car scenario? In the main car scenario, the schema is automatically created. Now, when is schema automatically created in the main car? When you do the installation process. When you do the installation process, when we install, it's going to ask us in which schema do you want to store. You give the name of the schema, automatically schema is created, and all the tables will be populated into that schema. Next question. In AT material, you did not hide the maktx in semantics after descriptive mapping. It worked fine without hiding. Then is it required to click hide? Yeah. It worked fine because we are working on the HANA Studio. But if you try to see the output from the end user point of view, when we are in the reporting tool to analyze the materials, then the difference will come. We only can see key, but when you click on an option key and text is not associated with key, then it will not produce text, but instead only key. It will actually make difference for the end user, but for a developer, it doesn't make any difference from the HANA Studio point of view. Selecting tables and giving relationship is all technical representation such as in code works, BUKRS, BUText, WARS, etc. Now, how to be understood based on these codes in any easy way to avoid confusion what the tables is actually belonging to it. Okay. Now, the only confusion here we have is because the technical names are in English. Now, if you have the same technical names in English, I think by now you should be able to understand everything. The only confusion comes because the tables have a different technical names like T001, TVKO, and the column names are BUKRS, BUText. But generally we know when we understand business, we can easily identify relationship between different business entities. Now, why like this is because when SAP designed the software was mostly designed in German. All the column technical names, all the table names that you see are not in English, they're in German. So when they're in German, if they're in English, we can easily understand. But again, it creates one more complexity to understand German language. And the technical names are in. So that is the reason there is little confusion. I also agree there is a confusion because the technical names are not generally used technical names. These technical names are in German language. So for this reason, I prepared one documentation. What tables and how these tables are interrelated to each other. If you see in the Dropbox, there's a documentation for tables and its relationships, important tables and their relationships for sales, for finance, for HR. So if you ask me any SAP consultant who has more than 10 years of experience, also I can say probably they can memorize from, it depends on individual to individual, but still if you memorize, probably you can memorize 300 or 400 tables or a maximum of 1000 columns. But SAP, if you see, but in SAP, if you see, there are more than a million tables and more than millions of columns are there. So if you ask me, really, it is not necessary to understand all the tables, but still, when a question is asked in an interview process, at least we need to be familiar few important tables from a particular business scenario we worked. Let's say we worked in SD. At least we need to be able to know 40 to 50 tables, at least 100 columns in these tables, because we already worked. So we work when we get familiar with these tables and columns inside these tables. So my suggestion is when you're working on a project, obviously we know we limit our work area. Probably we may work in sales, we may work in HR. It is not possible to work in every area in SAP because we know SAP is very vast. So when we're keeping a project on a specific area, we need to know specific tables relationships, and specific columns inside these tables. So when a scenario is asked, okay, can you tell me in your project what scenario have you worked? If that is the question, immediately we need to get those answers like what tables, what relationship, what columns, why we need to select this join, what is the purpose of this join, what is the business scenario. Like this, we need to get and explain in the interview. So obviously, if you ask me now, okay, tell me some tables in oil and gas, tell me some tables in utilities, tell me some tables in hatcheries. I am also not sure. But still, I am sure on the area that I have worked. So when we keep projects in the resume, we also need to understand very detailness of it, every detailness of it, from end to end. What was my start and what was my end? What was the end result desired? Everything need to be explained on how we actually executed the project. So simply to say, please limit ourselves to the only area we worked. Probably in a project we may worked on say 50 or 60 attribute views. At least we need to be able to explain about 10 attribute views and their tables and their relationships and their columns and what is the use of each column, how these tables are related, what are the different business entities. We need to explain in a very confident way. That is, I think that will be the expectation when the interview is taken. But later when we go on to the project again, we need to do the same work. If you don't know a table, there are several ways to know. F1, research on Google, do debugging, do a trace, ask any of your colleague or an ABAPer ask business, ask functional guy. This is purely coordination work. Only through coordination we will be able to gather this information. Or if a business consultant is already worked on a particular area, he will already know some tables. So it's actually a continuous process of identifying tables, identifying relationship between tables, and that is only through coordination. And only then we will able to Otherwise, it is very difficult to really memorize all these tables and relationship between these tables, unless and until we already know about these tables. So my only advice is, in the process of working, we will know more. But for now, whatever we work, whatever we keep in project, just try to analyze those tables. And that's why I prepared this documentation and kept in the Dropbox. So please go through that. At least we will have some understanding on the initial tables. Thank you. So HANA Cloud integration, this environment is going to be same. Yes, the backend is going to be same. But the HANA database is deployed not on-premise, is deployed in enterprise cloud. We have a different solution from SAP, especially for hardware. One is on-premise, the other one in cloud. On-premise means I'm actually having system with me. Cloud, the hardware is with a different hardware vendor. For example, like Amazon Cloud, Korean Telecom, Microsoft Azure. So these vendors provide hardware. I rent hardware from them. I install SAP HANA database in their hardware as a platform as a service. I'll install HANA database into their hardware as a platform as a service. On top of platform as a service, I install the software. That is software as a service. So first we need to have hardware as a service. Next, once we get hardware, then we install database. Database comes under platform as a service. Once we have database, on top of database, we have application running. And that application is software as a service. Hardware, on hardware we have platform, on platform we have software. So all together is provided by SAP. So you can take HANA database from SAP, or you can take or you can rent hardware from a different vendor and deploy the database from SAP to the prescribed vendor by prescribed, or these vendors are known as cloud partners like Amazon, Korean Telecom, Microsoft Azure. All these are partners who work closely with SAP to deploy HANA on their hardware. So next question. When applying filters based on joins in specific language, is it all in quotes numbers like EGC145? So how to identify these codes belong to this language? Okay. So what we have to do is, when you go to the source system, for example, let's say this is a table. So this is a table. I execute this table. Here you have SPRAS, language key. I open this. You see there are different codes that you can see here. So all these are different codes that you see here. So if I go back, and here you have SPRAS, so you can see these codes and the name of each code. like DA Danish, E in English, F for France. So please provide the latest material for HA300. Yeah, HA300 is available in the latest materials. You have a folder called HANA latest material SPS 10. Please refer to that folder. In that folder you will have HA300, which is SPS 10. Can you explain sys schema? So sys schema is a schema that is generated by system. So we discussed two system schemas. One is sys underscore BI. The second one is sys underscore BIC. In sys underscore BI, we have timetables. We have metadata tables. In sys underscore BIC, we have column views. So both these system schemas are installed when we install SAP HANA database. So do we always have to cross-check with ECC tables to confirm we get the right data to output? If you check, it is better. But if you don't check, if you're confident, it's okay. But if you can check, it's always better to at least complete the unit test from our side. So again, one more question. Is there a rule to perform hide in semantics after selecting the keys? There is no rule to perform. There is no rule that we have to hide. But if we don't hide, what happens is these columns also will be displayed in the front end. So what happens is it creates a confusion. We already done a text join. Sorry, we already done descriptive mapping. We already mapped key with text, and still we insist to show text in a separate column. So it creates a confusion. If you don't, it show. But again, now user will see key and text, and then you have text as a separate column. So if you don't, you can still show. Technically it is possible to show, but if you want to hide, you can hide. But always better is to hide, because already we done key and text functionality. Okay, sure. I will, whenever the use case comes for ABAP, surely I will discuss about them. Yes, I'm going to explain other schemas also. As and when the new schemas are there, I'm going to explain those schemas as well. So that's all questions we have for today. Thank you everyone and have a great weekend. I'll see you on Monday again. Please keep reading materials. I encourage everyone to read materials HA100. Thank you and have a lovely weekend and see you on Monday. Good day to everyone. Good morning and good evening. Thank you. So I have one last question coming here. What is operational reporting? Operational reporting is nothing but reporting on the OLTP system. OLTP, online transaction processing. So online transaction processing is where you insert data. On the same system, we do reporting. We don't have to move data from one system to a different system. Operational means what is happening in my business at this point of time. I want to understand my operations of my business. Operations data that is generated, I would like to know at this point of time what are the new materials created. Who are the new customers? Operational reporting. I will update the assignments this week. I will update the assignments this week. You will find the assignments in the Dropbox folder. Thank you. Thanks everyone once again. See you on Monday. Thank you.